Expanding and factoring. We multiply or expand to represent a product as a sum. So if we had this product a plus 1 times a plus 2, how could we expand it and write it as the sum of multiple terms? Well, we can do it in a couple of ways. The first way that we're going to do is visually. If you multiply a times a, you would get a square whose area is a squared. If you multiplied 2 times a, we would have a length of a and a width of 2, or 2 single a area values. And then we would have, for 1 times a, we would have a. And then for 1 times positive 2, we would have 2 blocks in a row, or plus 2. Again, we can also represent this algebraically. If we were to take this first a value and distribute it through to both of our terms in the second binomial, we would get a squared, and then a times plus 2 is plus 2a. And then we're going to take this positive 1 and we are going to distribute it through the second set of parentheses as well. So plus 1 times a is plus a, and plus 1 times positive 2 is plus 2. And now we see that with this 4-term polynomial, we have some like terms. We have a plus 2a and a plus a. So when we add these together, we get plus 3a. And that tells us that our polynomial, or our product to a sum, simplifies to a squared plus 3a plus 2. The other term is called factoring. We usually factor to represent a sum as a product. So in this case, if we had b squared plus 1, 2, 3, 4b plus 3, how could we rewrite that as b plus 1 times another factor? So we would see what's in common here. Well, we have a b squared and a b, so if I factor a b out, we'll end up getting a b. And if we factor out a b from 3b, we would get a plus 3. So then we would have b plus 3 times b plus 1 as our final solution down here. Now we can also do this algebraically by first splitting up the 4b into plus 3b and plus b. Then we can group these together into 2 sets. And in this first set, we would factor out a b, and we would be left with b plus 3. And in the second one, we can factor out a plus 1 and be left with b plus 3. And then notice we have this common factor of b plus 3 in both of these terms, so I can factor that out as well. And when doing so, we will be left with b plus 1 as our second factor. To factor a mathematical expression means to rewrite a sum of 2 or more terms as an equivalent product of factors. So in this first example here, we have 2 terms that are added together, or we have a sum. And in this sum, we have 2x and a positive 10. Well, 2 and 10 are both even, so I can factor a 2 out of both of those. And when I do that, you're dividing out, or dividing by that common factor that you're pulling out. So we pulled the 2 out, so then if we divide 2x by 2, we get just 1x, and if we divide positive 10 by 2, we get positive 5. And this is one term because it is now a product. You could also use something called substitution to better understand why this is called one term. If we were to let u equal x plus 5 in this expression, we could then rewrite it as 2u. Clearly, 2u is one term. Well, the same thing generally applies to this one. When you just have a product, you have one term. Let's look at another example of this. So we have this sum, 8 times x to the third times y squared plus 16x squared y squared plus 24x y squared. We have 3 individual terms here. If I look at all of our coefficients, 8, 16, and 24, all of those numbers are divisible by 8. So we're going to factor an 8 out. So we're going to divide all of these by 8. So we stick that common factor out, and then we divide each of the terms by 8, and we would be left with 1, 2, and 3, which are the coefficients of the terms remaining in the parentheses here. Now let's look at our x's. We have x cubed, x squared, and x. The lowest power of x that I can divide by is the first. So we're going to divide each of these by 1x. We can also do something similar with y. We have y squared, and y squared. So we can divide all of these by y squared. So 8xy squared, that's my common factor that I am pulling out. And then we're going to do the division to get all of the remaining terms. So 8 divided by 8 is 1. X cubed divided by x is x squared. Y squared divided by y squared, they cancel each other out or go away. So that's why the remaining term left for the first one is x squared. Now let's look at the next one. 16 divided by 8 is 2. So that's why we have this 2 here. X squared divided by x is x to the first. So we have it here. And y squared divided by y squared is 1, where they cancel each other out. So that's why we have 2x remaining over here. And then 24 divided by 8 is 3. And x divided by x, they cancel each other out. And the y squareds also cancel each other out. So we're left with 3 as our constant in the second factor here. And again, this note, terms are mathematical expressions that are separated by addition or subtraction signs that are not contained in parentheses. Again, if we were to use substitution with this second one, and we said that u was equal to x squared plus 2x plus 3, we could rewrite this one-term product as 8uxy squared. And clearly, this is one term. And again, if you were to substitute this back in for u, you get this exact one-term expression that we have as our answer. Determine the greatest common factor, and then factor the greatest common factor out to write the sum as an equivalent product of factors. So here's our example. We have 6x to the fourth minus 15x to the third plus 3x squared. And we are going to rewrite this as the greatest common factor times the trinomial that remains. So first, let's examine our terms to determine what is the greatest common factor. Let's first look at our coefficients. We have 6, negative 15, and 3. Well, I know that 3 divides into both 6 and negative 15. So 3 is going to be that greatest common factor as a coefficient. So we're going to write down that coefficient of 3. And now let's look at our variables. We have an x to the 4th power, an x to the 3rd power, and an x to the 2nd power. Well, the lowest degree or exponent that we have that can be factored out is x squared. Because x to the 4th can be written as x times x times x squared. X to the 3rd can be written as x times x squared, and this has an x squared. So 3x squared is going to be our greatest common factor. And then if we divide each of our terms that we have here by our greatest common factor, what will we have remaining? So divide this by 3x squared. When we do that, we are going to have 6 divided by 3 is 2. And then x to the 4th divided by x squared is x squared. And again, we factored a 3x squared out. Factored out a 3x squared. And now let's divide the 15x to the 3rd by 3x squared. Well, negative 15 divided by 3 is negative 5. And then x to the 3rd divided by x to the 2nd is x to the 1st. And we don't have to put the exponent of 1 in our solution here. We can just write it as x. And then we have positive 3 divided by 3, which is 1. And then x squared divided by x squared is 1 also. So we just have 1 here. So the trinomial factor that we get when we factor out the greatest common factor is 2x squared minus 5x plus 1. Yep, it all matches. Determine the greatest common factor and then factor out the greatest common factor to write the sum as an equivalent product of factors. So the first thing that we are going to look at are our coefficients in this first problem, 4 and negative 7. Is there a common number that divides them both? Besides 1, no, there is not. So we're not going to divide by 1, 2, well, we can divide by 1, but that doesn't change anything. But we're not going to divide by 2 or 4 because they don't divide into 7 evenly. Now let's look at our variables. We have m to the 3rd and we have an m to the 2nd. The lowest degree of the variable m is m to the 2nd. So we can divide both of these by that value. Now let's look at our n's. We have n to the 1st power and we have an n to the 2nd power. So the lowest common factor, or the greatest common factor, I should say, between the n and n squared is just n. So we're going to divide both of these terms by m squared n. And when we do that, we will get 4 divided by 1, which is 4. M to the 3rd divided by m to the 2nd is m to the 1st. And then n divided by n, they cancel out. Then we have minus 7 divided by 1 is 7. M to the 2nd divided by m to the 2nd is 1. And then n to the 2nd divided by n is just n. So the equivalent product of factors for this first one is going to be m to the 2nd times n times the quantity 4m minus 7n. Now let's try the next one. In the next problem, we have 100x to the 5th minus 20x to the 3rd plus 30x plus 50. Let's first look at our coefficients. 100 -20, +30, and -50. What's a common number that divides all of them? Well, the answer here is 10. So if we divide all of these by 10, we can rewrite it out here. And then we will fill in the parentheses after we determine if any variables can be factored out too. We have x to the 5th, x to the 3rd, x to the 1st, but this one doesn't have any x's. So actually we can't factor any x's out. So now let's just simplify this. 100 divided by 10 is 10, and x to the 5th still remains. And then we have minus 20 divided by 10 is 2, and x to the 3rd still remains, plus 30 divided by 10 is 3, and we still have an x there, and then minus 50 divided by 10 is 5. All right, now let's look at our last one that we have here. We have a 1/2 x squared minus 1/2 x. Well, we look at both of our coefficients and they're both 1/2. So I know that we are going to be able to factor out or divide by 1/2 for both of these terms. So let's write it there. And now let's look at our variables and their exponents. We have an x to the 2nd and an x to the 1st. Well, x to the 2nd is x times x. So I can divide both of these by an x, or factor an x out. And now let's do the division and simplify. 1/2 divided by 1/2 is 1, and x to the 2nd divided by x is just x. We still have the subtraction sign, and then 1/2 divided by 1/2 is 1, so these cancel out, and we can also show that these canceled out. And now we have x to the 1st divided by x to the 1st. Well, they cancel out too. So is there a 0 or a 1 here? Which one is it? It's actually going to be 1 because we are doing division here. And any number or any variable divided by itself is equal to 1. So we need to make sure that we keep the 1 in that place. So our final answer to this third one, factoring it out, would be 1/2 times x times the quantity x minus 1. And we can check all of our answers in this pull tab. And they all generally look correct.